Hello everyone. Today we will look at some more problems on exponents. I've taken one example here. Let's try and solve this one. Now, the first step would be to open the bracket and write the product of the powers. When we write the product of the powers, we will try and follow the alphabetical order so that it's easier for us to recognize the like terms. So x to the power mn divided by x to the power lm into x to the power ln divided by x to the power mn. Now here we can see we have in the numerator x to the power lm and x to the power lm in the denominator also. So we can cancel these two. Similarly, we have x to the power mn here, x to the power mn here also. We can cancel these two. And likewise, x to the power ln is here, x to the power ln is here. So the value of this will be 1. Now let us look at another problem. In this case, under the sign of the radical, we have different values. What does that mean and how do we solve this one? To solve this one, first we will convert this radical sign into fractional exponent. We will write this as x to the power L divided by x to the power m whole to the power 1 by Lm. Since within the radical sign there is Lm, so we write 1 upon Lm multiplied to x to the power m divided by x to the power n whole to the power 1 upon mn multiplied to x to the power n x to the power l whole to the power 1 by nl. Now we will open the bracket and assign same power to each expression. So we can write it like this: m by lm x to the power m divided by mn x to the power n divided by mn x to the power n divided by nl x to the power l divided by nl. Now what we can do is we can cancel out the powers which are similar. For example, here l and l cancels out, here m and m cancels out, here also m and m cancels out, here n cancels, here also n cancels, and here we cancel l also. So we can write 1 upon m divided by x to the power 1 upon l, x to the power 1 by n is left here, x to the power 1 by m, x to the power 1 by l divided by x to the power 1 by n. Now we look at similar terms in the numerator and the denominator and cancel out. You have x to the power 1 by m cancels with x to the power 1 by m. X to the power 1 by n also cancels with x to the power 1 by n, and x to the power 1 by l cancels with x to the power 1 by l. So what is left? The final answer again here is 1. Okay, let's look at the third case. Here, first what we do is we remove the negative exponent by writing the reciprocal. So we can write here 1 upon a plus 1 upon b. Since the power will be 1, I am not writing the power. In this case, the power is 2, so we will write 1 upon a square minus 1 upon b square. So first we will simplify within the bracket by taking the LCM. So when I take the LCM of these two will be AB. Already A is there, so B into 1 is B, plus B is already there, A into 1 is A, divided by, here the LCM will be A square, B square. A square is already there, so we write B square minus a square. So this is b plus a divided by ab. Now we can write this as multiplication and then again write the reciprocal. So it's a square b square by b square minus a square. We can write it individually, b plus a divided by ab multiplied to a square b square. Here we can use the expansion a square minus b square formula. We can write this one as b plus a multiplied to b minus a. Now let's look at what is common and cancel out. B plus a is common here, so we can cancel out like this. Here ab is there, here a square b square is there, so we can cancel this square term also. So what we are left with is ab divided by b minus a. Now this is simplified. Now let's look at this fourth case. In this case, you have to prove the left hand side is equals to right hand side. So in order to solve this type of problem, we either start from left hand side or right hand side and try and get the same answer. In this case, we will start with left hand side because it's always easier to reduce than to expand. So first we will write down the same thing again, a plus b to the power minus 1 multiplied to a to the power minus 1 plus b to the power minus 1. So in the second step, we will write the reciprocal to get rid of the negative exponent. Here also we write 1 upon a plus 1 upon b is equals to 1 by a plus b. Now here we will try to take the LCM. So LCM is ab. So a is already there. This is b plus a. Let's rearrange it. We can write b plus a also as a plus b divided by ab. So ab and ab cancels. Then we get 1 upon ab, which is same as our right hand side, hence proved.